In this video, I will be explaining Boolean logic gates. So, in the 1800s, around 1830 or so, Boole discovered this, that if you just base things on true and false, you could set up logic without the kinds of assumptions you would have in a traditional logical system. And then in the early 1900s, Shannon discovered that you could convert all of Boole's logic into ones and zeros and electrical signals, and you could just run it mechanically. Anyhow, so there's many ways of representing these, but one of them is a truth-false table, or this is a 1-0 table. So this is explaining exactly what happens. So your input is A and maybe B if you have two inputs. And so this with the relay, also called a buffer, and a not. This just shows, so if you have a 1 and your not is 0, so if you have a 1 and it's not, you get 0. So if it's 0 and it's not, you get 1. And likewise for and, or, nor, XOR, and XNOR. I don't think I need to go through these in detail. It's there for reference. But this is how you draw the wire diagrams for how you would actually do a circuit. There are an extremely large number of ways you can wire these. This is just one of many valid ways of wiring them. But it is critical that they do produce an output consistent with the truth table. So for not, as you can see here, we have electricity flowing in from like this from a battery or whatever, and then we have a control signal which comes in here, and it can turn this transistor on or off. If the transistor is on, the current can flow through. If it's off, then the current will be stopped here, so it'll go out this wire. And so that means if we have a 0, no current, then if we have 0 current, so then this is off, then we have a value of 1 coming out here. And then if we have a 1 current flowing through this transistor, current flows out here to a ground, and so it's just lost. So it's a 0. And then the relay is it's simpler. It's just passing the signal along, and so you have a gate. And so if the signal's on, gate sends the signal through. Here the output's down here instead of up here, and if it's off, it's off. Moving on to and, as you can see here, current flows through here, and there's two control inputs here for A and B, and both have to be on for the current to flow through, which is consistent with the truth table. And then with NAND, what I did is, you see here, these are the symbols for AND, NAND, OR, etc. So with some of these later ones, I'm using the symbol for the circuit which we've already explained to build the later circuits. So in NAND, it's pretty simple. When you have an N, what you do is you just stick a not after the thing. So it's like and, then you stick a not after it. And then with OR, it's a parallel thing. So we just divide the circuit in two. So then we have two charges going through, or none. And even if just one or both of these transistors are on, then the circuit will flow through here, and we'll get an output. This is a O, not a 0. We'll get an output of 1. And if none of them are on, we'll get nothing. That's OR. NOR is not OR. And so what you do there is you just say, okay, if OR is true, then NOR is false. So you just add a not to the NOR. For XOR, it's like OR, except for XOR, it's like OR, except we can't have both be true for an XOR. So we got to cut that out. So that would be true if it's an and therefore we have to divide the circuit and say, okay, so we have and here and a not, so we have a NAND essentially. I could have reduced this to a NAND, and I should have. So let's see. If I can just reduce this simply to a NAND. Sorry about that. So just a NAND. And then, so we have an OR here and a NAND. And so the NAND, if the NAND is true, then it will stop flow. So basically, if the OR is true, it'll send a signal from the inputs through to here. And then for that charge to go all the way to the output, this transistor has to be on, which means AND must be false. And that's how we do the XOR. And then for XNOR, it's like, again, we just have like the XOR and we add a NOT to it, and thus we have XNOR. That's it for this video. In the next video, I will explain things like how we build conditionals and arithmetic, building on these and related work control flows.